Okay, so we've got a detective story on our hands. But this is no ordinary crime scene. Nope, this one's millions of miles away, on the cold, red surface of Mars. And the clue at the center of it all? Well, it could be one of the most important discoveries in all of human history.
So, let's set the scene. It's July 2024. Our detective, the Perseverance Rover, is exploring a place called Jezero Crater. Now, this spot wasn't picked at random. Billions of years ago, scientists are pretty sure it was a lake, fed by rivers. The perfect kind of place for life to get started. And right there, on what used to be a riverbed, the rover spots it, this meter-long, arrowhead-shaped rock that the team nicknamed Chebacheva Falls.
And this is where things get really interesting. See, Chebacheva Falls wasn't just some boring old rock. Its surface was covered with these strange dark markings. Looking at the pictures, the science team started calling them leopard spots and poppy seeds. Right away, they knew they were looking at something totally new, a clue that just begged for a closer look.
And that leads us to the heart of this entire investigation, the one question that has scientists all over the world just buzzing. Could these weird little spots be the first real, credible evidence we've ever found for ancient life on another planet? I mean, NASA's acting administrator even said this is, quote, the closest we have ever been to discovering life on Mars. So yeah, the stakes are about as high as they can get. To get any answers, Perseverance had to switch gears. It stopped being an explorer and became a forensic analyst. It was time to decode the secrets that were locked away inside those mysterious spots. Luckily, Perseverance came prepared with an incredible detective's toolkit. It used an instrument called PIXL to map out the exact chemical elements with X-rays. Then, it zapped the rock with lasers using its other tool, SHERLOC, to hunt for the basic building blocks of life. This wasn't just a quick glance. This was a full-on microscopic chemical interrogation of the rock. Now, what they were looking for has a very specific name, a potential biosignature. That's a super important term here. It's not proof of life. Not yet. The best way to think about it is like a fingerprint found at a crime scene. It's a huge clue that points to a biological cause, but you've got to rule out every other possibility before you can be sure.
So what did the instruments find? Well, they found a chemical cocktail that is just, wow, it's incredibly compelling. The spots had organic carbon, which is the very foundation of life as we know it, but it wasn't alone. It was mixed with specific minerals of iron, sulfur, and phosphorus. Put that all together, and what you have is basically a recipe for energy. And here's the real kicker. Back here on Earth, that exact chemical mix, organic carbon, iron, sulfur, phosphorus, is like a five-star meal for microbes. Ancient bacteria on our planet use these kinds of chemical reactions to basically breathe minerals and power themselves. So finding this exact same setup on Mars, that's a truly stunning parallel. And if we zoom in even closer, the specific minerals each tell their own part of the story. Those bigger leopard spots, they contain a mineral called greigite. Here on Earth, certain types of bacteria are known to produce that exact mineral. And the tiny poppy seeds, that's a mineral called vivianite, which often pops up right next to decaying organic stuff. Each mineral is like another witness corroborating the story. But hey, any good detective knows you have to consider all the suspects, right? Is this truly a sign of ancient Martian microbes? Or could there be another explanation, one that has nothing to do with life at all? So we basically have two main suspects for how these spots got there. Suspect number one is biology. Ancient Martian microbes living in the mud, munching on the chemicals in the rock to survive. Suspect number two is pure geology, just some non-living chemical reactions that happen to create the same stuff. Now that can happen, but it usually requires some pretty specific and pretty extreme conditions. And this is where the alibi for the non-living suspect starts to look a little shaky. When the scientists looked at the area around the rock, they found zero evidence of the crazy heat or superacidic conditions that would be needed to form these minerals geologically. The scene of the crime just doesn't match the geological story. But even with all this compelling evidence, the science team is being incredibly careful. And this quote from Katie Stack-Morgan, the mission's project scientist, just sums it up perfectly. Claiming you found signs of life on another planet is one of the most extraordinary claims you can possibly make. And that means you need an absolutely extraordinary amount of evidence. And that caution, it comes from decades of experience. The search for life on Mars has been a really long road, and it's been filled with some tantalizing clues and, well, a few false alarms. It's a history that has taught the entire scientific community to be extremely careful.
Let's just quickly flip through the old case files. Way back in 1976, the Viking landers got results that looked positive for life, but other tests found no organic molecules, leaving a 50-year mystery. Then in 1996, a meteorite from Mars seemed to have fossilized microbes, but that was later explained by geology. And for years, we've seen these weird spikes of methane gas. Could be life, could be geology. Every single one of these moments has made us smarter, and it's all led up to right now, with what is by far the strongest clue yet.
So, how do we finally crack this case once and for all? The rover has done everything it can from Mars. To get a definitive answer, we have to take the next, absolutely crucial step.
As strong as all this evidence is, it's still what you'd call circumstantial. Perseverance is an incredible field geologist, but it doesn't have the power of the most advanced labs we have here on Earth. To go from potential biosignature to proof of life, we need to get a piece of that rock under our own, most powerful microscopes.
The final verdict just can't be delivered from millions of miles away. To truly, finally close this case, the evidence has to come home.
And believe it or not, there's a plan. It's one of the most ambitious things we've ever tried. Perseverance has already done its part. It actually drilled a core sample from the rock, nicknamed Sapphire Canyon, and sealed it up in a super clean titanium tube. The next step is this incredibly complex mission with NASA and the European Space Agency to go to Mars, pick up that tube, launch it back into space, and bring it all the way home to Earth.
It is an absolutely audacious plan. But if it works, that tiny piece of Martian rock, no bigger than a piece of chalk, is going to be studied in ways we can only dream of doing on Mars. And it could, finally, give us a definitive answer to maybe the most profound question we can ever ask. Are we alone in the universe? For now, the evidence is sealed, and it's waiting. The case remains open.